What if I told you that the ground beneath your feet hasn't always been there? That the continents we live on were once part of a giant supercontinent, or even submerged under ancient oceans? Today we're taking you on a journey through deep time, from Earth's fiery birth to the majestic shifting of continents. This is the entire history of how the continents were formed in just 10 minutes. Our story begins not with land, but with chaos. 4.6 billion years ago, a young star, our Sun, had just been born. Around it, swirling clouds of dust and gas collided, fused, and formed the Earth. But this was no paradise. Earth was a molten hellscape, a sea of lava bombarded constantly by asteroids. There were no continents, no oceans, no life, just a fiery ball of rock reshaping itself with every impact. Then something extraordinary happened. A Mars-sized planet named Theia crashed into Earth. The explosion was so massive it nearly shattered both worlds, but from that violent impact the debris coalesced and formed the Moon. This impact didn't just give us our lunar companion, it also helped stabilize Earth's tilt, setting the stage for the continents to come. As Earth cooled, something miraculous began. The molten surface hardened into a primitive crust, the earliest version of land. But don't imagine it like the continents we know today. These were tiny patches of crust, floating like scabs on a molten sea. Scientists call them cratons, the ancient cores of continents. The first known rocks formed in places like present-day Canada and Australia. These ancient cratons would later grow, merge, and become the backbone of future continents. Meanwhile, volcanic eruptions spewed gases into the atmosphere. Steam condensed and rained for millions of years, forming the first oceans. Water met rock, and the Earth began to change. Have you ever watched ice cubes bump into each other in a glass of water? That's what Earth's crust started to do, but on a planetary scale. Beneath the crust, heat from Earth's core caused the mantle to flow. This motion cracked the crust into massive plates, a process we now call plate tectonics. These plates collided, pulled apart, and slid past each other. Over time, they formed mountains, ocean basins, rifts, and eventually continents. One of the earliest known microcontinents was Ur, around 3 billion years ago. Later came Kinnorland, Columbia, Rodinia, and others. Each time, land masses would collide and break apart again, in a dance lasting billions of years. The Earth was shaping itself with every tectonic movement. Fast forward to 1.1 billion years ago, and the Earth was entering its teenage years. Land masses had clumped together into a single giant supercontinent, Rodinia. Rodinia was a vast, barren landscape, silent except for the howling wind and rumbling volcanoes. There was little life, and the climate was harsh. But its formation was key. Rodinia altered ocean currents, reshaped the climate, and possibly triggered one of the greatest ice ages in history, the Snowball Earth. Eventually, Rodinia broke apart, like all before it. But its legacy laid the groundwork for what came next. Now we arrive at one of the most iconic stages of Earth's past, Pangaea. Formed around 335 million years ago, Pangaea was the ultimate landmass, a single continent that stretched from pole to pole, surrounded by a vast ocean called Panthalassa. Dinosaurs roamed its forests, giant insects buzzed through its jungles, life was thriving, but deep below, tectonic forces were tearing Pangaea apart. Around 175 million years ago, it began to break. first into Laurasia in the north and Gondwana in the south. These would eventually split further into the continents we recognize today: Africa, Europe, Asia, North and South America, Australia, and Antarctica. As Pangaea broke apart, the modern world took shape. Africa drifted northward, forming the Mediterranean Sea. India slammed into Asia, pushing up the Himalayas. South America split from Africa, leaving behind a jigsaw-like coastline. Australia broke off and drifted east, becoming the isolated land we know today. Each continent still rides atop its own tectonic plate, and they're still moving. In fact, the Atlantic Ocean is growing wider every year, and in millions of years, today's map will look entirely different. Continents didn't just shape the land, they shaped life itself. When continents drifted apart, species were isolated and evolved differently. That's why kangaroos live in Australia and nowhere else. It's why fossils in South America match those in Africa. They were once connected. Tectonic movement caused mass extinctions, created new ecosystems, and changed the course of evolution again and again. Without continental drift, humanity might not even exist. So what comes next? Scene 2, the future of continents continues. Geologists believe the continents will merge again, forming a new supercontinent, maybe Pangaea Ultima, Nova Pangaea, or Orica. Scene 3, the future of continents continues. It might take 200 to 300 million years, but Earth is still alive, still moving, still changing. Our cities, oceans, and even mountains are just temporary features in Earth's long story. From fiery chaos to drifting continents, Earth's history is a tale of destruction and rebirth. Every continent has a story, etched in rocks, mountains, and shorelines. And though we may think of land as solid and still, it is anything but. This was the entire history of how continents were formed in 10 minutes. If you enjoyed this journey through deep time, make sure to like, subscribe, and tell us in the comments. Which part of Earth's history fascinated you the most? Thanks for watching, and see you in the next video.